MS Exchange Implementation and Planning on AWS. Our presenter is Schoo, Solutions Architect for Amazon Web Services, and our facilitator is Colin White from AWS Marketing. Colin?
Thank you, Carrie. Hello, and thank you everybody for joining us for this AWS webinar. Today we'll learn about planning and implementation of Microsoft Exchange Server 2010 in the AWS Cloud. The content is derived from a white paper published in July of this year, written by AWS Solutions Architect Schoo and Senior Product Manager Shankar Sivadasan. The guide walks through all of the implementation steps in detail, showing you how to create an example solution. The presentation will give an overview of that process, highlight key concepts and considerations such as sizing the solution, implementing it, and testing it. Delivering today's presentation is one of the co-authors of the guide himself, Schoo. Thank you for joining us today, Ulf.
Thank you for having me, Colin. Great, so let's get started right away. All right, so as you are probably aware, Microsoft Exchange is still one of the most mission-critical messaging platforms in the enterprise today. It is in the AWS Cloud, we provide a suite of infrastructure services that enable you to deploy Exchange Server in a highly availability, affordable, and fault-tolerant manner. By deploying Exchange Server in the AWS Cloud, customers can leverage the powerful functionality of Exchange along with the flexibility and security of AWS. So let's dive into the different type of concepts that we discussed in the white paper. But before we get started, we want to make sure the white paper that we published was written with the Exchange administrator in mind. It was written by an Exchange administrator for an Exchange administrator. So we certainly glance over many pieces of key concepts that are key to Exchange and that you as an Exchange administrator are already familiar with. And instead we focus on the key points that are different where it comes to deploying Exchange in the AWS Cloud. So you should be familiar with the concepts of EC2 and Amazon VPC, general Windows Server 2008, Active Directory and DNS, and as we also talk about database availability groups, so the concepts of Windows Server failover clustering, and of course Exchange Server. Moving on the high level, I just want to give you an overview of how you can license Exchange in the AWS Cloud. Microsoft License Mobility through Software Assurance gives qualifying Microsoft Volume Licensing customers the flexibility to deploy Windows Server applications with active software assurance on Amazon Web Services. So you have, in the pay-as-you-go model, you have AMIs for Windows Server in all different type of SKUs. I think in total, as of today, it's about 19 different type of Amazon published AMIs that we have out there. And then for other software applications that fall under the umbrella of license mobility through software assurance, you can bring your own license to the AWS Cloud if you are qualifying customers. So SharePoint, Exchange, and Dynamics CRM, Link, and other products would fall in this category of bring your own license to the AWS Cloud. So today we walk through this presentation. We talk about the planning aspects, as this is at the heart of any new Exchange deployment or even a migration that you want to do and perform to the AWS Cloud. We talk about concepts for site resiliency and high availability as they apply in the AWS Cloud. We talk about specific pieces around configuring for high availability and how you would do these things given a shared compute and network environment in the cloud. Talk a little bit about the sample deployment scenario that we have published with the white paper and the templates that go with that, and wrap it up then in time for hopefully leaving a little bit of time for some Q&A here at the end. The white paper is all designed to actually give you in the sample deployment a summary of a small business scenario. So we use the small business scenario throughout, the scenario being defined as a 250 mailbox deployment, designed to provide cost-optimized high performance and availability, stretched across 2 AWS availability zones. Some assumptions we made for the sizing of that deployment was around a 5 gigabyte primary mailbox quota, 5 gigabyte archive, about 100 messages sent, received per user per day, and about an average message size of 75 kilobytes. Then with regards to our assumption when we looked at load test scenarios and proper performance, we assumed like a 60% Outlook Anywhere, 30% Exchange Active Sync, and 10% Outlook Web App utilization profile for this sample deployment. Your specifics may vary, and you will want to plan for that using the tools that we will subsequently talk about and discuss. So I wanted to give you an overview of the architecture of the small scenario that is there. The nice thing about this is as it's right now really very simple and almost simplistic in the way it's deployed here, the concepts utilized here can be stretched out and can be multiplied to actually have a much larger deployment. So the separation of Active Directory infrastructure and instances stretched out in different availability zones, providing high availability of the Active Directory infrastructure, having mailbox servers that are designed in a way to have logical and physical separation of the mail network and the replication network. And then, of course, as all this is in a VPC, in an Amazon Virtual Private Cloud, we have administrative ingress and egress into the environment. All that properly configured via the right routing that ensures mailbox instances and Active Directory instances are private, so they are on a private route, and the instances that provide administrative ingress and egress, like an added instance for egress and remote desktop gateways for ingress into the environment, they are on a public route directly going to the Internet gateway. Oops, let's see. So let's talk a little bit about planning your deployment. When you plan your deployment, you go through a certain process, and the key point of this whole presentation, if there's one key takeaway that you take from this, is the steps involved are not any different in the AWS Cloud than what they are in your on-premise world. So you would design your deployment on AWS just as you would for a physical hardware or on-premise, using the standard tools such as the Microsoft Exchange Role Requirements Calculator. You would treat your AWS deployment and its availability zones just almost like additional logical data centers, and follow the general Microsoft guidance for Exchange role and service availability design. You think through all the capabilities, the limitations, and performance characteristics of the different infrastructure services that are provided by AWS. So processor sizing, memory sizing, storage sizing, log replication sizing, network sizing, all these are pieces that you would work through in the context of the role requirements calculator, and where you plug in the values that you need. We have given in the white paper some examples, especially when it comes to figuring out what the descriptions of our instance types means for you, and how you would have some form of approximation to values as they are represented in the real physical world. So if you haven't done so, take the white paper we have published and take a look at this. This will help you use the role-based calculator to the fullest extent, just as you would use it in the on-premise world. Once you have produced the candidate design and you deploy this candidate design into production, you want to test the storage components specifically. Will they perform to the degree of what you anticipate the IOPS are going to be in that environment? So using the usual tools like jet stress in that environment is going to be a key part for you to verify that the design that you have and the architecture that you have created will perform as expected. Then once you have actually installed Exchange and just before putting it in production, you verify the server performance, and doing so you can use tools like LoadGen in the AWS Cloud just as you would use it in an on-premise world. Let's move on here. So designing for site resiliency and for high availability takes a couple of points that you have to take into consideration, right? You want to make choices about where you deploy your infrastructure. So AWS has 9 regions around the world. Each of the regions has 9 geographic regions. Each of the regions has 2 or more availability zones. Again, as I said earlier, think in the context of Exchange, think of availability zones and as kind of physical data centers that are in geographically different locations. When you also design for site resiliency and high availability, you want to think about your Active Directory site design and the pieces, the trade-offs that you make around that. So considerations like, do you want to have a single Active Directory site or multiple Active Directory sites? All of those have advantages and drawbacks that you want to think through. For example, when you have a single site Active Directory design, you can rely on the built-in failover mechanisms that Active Directory provides in case one of the services, like a hub server or edge transport server going down in one AZ, and Active Directory knowing of the same functional server in a different AZ and automatically routes traffic in the right direction. Cross-regional deployments are big considerations that you want to consider very carefully as you traverse at that point the public internet, and so make allowances for proper security for cross-regional deployments. Also consider latency of the public internet that you will have there. And last but not least, client access load balancing. Client access load balancing for CAS servers is one of the ways you can reach great scale and reliability of your Exchange deployments. In Exchange 2010, the ELB solution from AWS doesn't provide sufficient, is not a load balancing solution, so you have to resort to third-party enterprise class load balancers like an F5, like a Citrix NetScaler or a Riverbed Stingray, or any of the other approved and tested load balancing solutions that Microsoft offers. Looking ahead towards like Exchange 2013, that changes, as in Exchange 2013 different protocols are being used there for load balancing, and so the solution will look slightly different, and we will write about this in the near future here as well on Exchange 2013. let's see what we want to talk about next here. Yeah, if we want to configure our solution for high availability for Exchange, then we certainly have to deal with a couple of quite gnarly problems. Your mailbox servers, in an ideal way, in order to create separation of mail network and replication networks, those instances sit in on different subnets. These subnets have different type of security groups assigned. As in our specific scenarios, the mail network, the MAPI network, actually then directly routes out to the public internet for SMTP mail traffic, incoming and outgoing, as well as then for client access. As in our specific scenario, as we wanted to be cost effective, we used a combined server role there. On the other hand, the same mailbox server actually sits also on a DAG network, on a replication network. So, and this is entirely isolated, an entirely isolated network that its only purpose is to perform replication of the database availability groups between the instances. Setting those things up within AWS is fairly straightforward. You just create some separate ENIs, additional ENIs, and you have to actually create a second one in addition to the default one that comes with every instance. You will need to assign additional secondary IP addresses to the ENI associated with the MAPI network, so with the mail network. We need that for the underlying cluster to work properly, and you need to configure this then in Windows as well as in on the instance itself. So, when the DAG network actually crosses multiple AZs, you will also have to set up routing between the instances. So you want to go set up an individual route between the network interface in availability zone 1 and the network interface in the availability zone 2, and ensure that that traffic properly routes. And last but not least, then obviously a standard configuration task is for Exchange then to disable replication on your mail network and enable replication on the availability group network, just in general. But these are not any different tasks from what you would do in your on-premise environment. In general, when you deploy Exchange on AWS, the steps involved are almost the same as moving it to a new data center. Think on-premise, you got a new data center, you want to get your new Exchange environment up and running. And in this case, all it means, translated to AWS, it means you create a new VPC, you create the subnets, you create the routing, you launch your instances, and based on the output of your role-based calculator, you provision the right EBS volumes, the elastic block storage volumes in AWS. You validate your storage design using jet stress. You install Exchange and the Exchange server role. And if you actually moving from one installation on-premise to the cloud-based world, then you redirect your service entry points to the new AWS infrastructure. You may perform online mailbox moves to AWS mailbox servers, and then may even add public folder replicas to AWS public folder databases, and perform functional testing with pilot user mailboxes. Move the remainder of the mailboxes to AWS, and at that point, you can actually decommission your on-premise environment and operate everything out of a cloud-based environment, and it behaves the same as it would have been in on-premise world. The only difference is that you actually don't have to manage the underlying infrastructure anymore, just focus on your Exchange environment. So for the sample deployment scenario, as we introduced earlier during the presentation, we said it's a small business scenario, and we deploy this in three parts. The sample templates provided with this white paper actually give you the opportunity to reliably and repeatedly actually play around with this environment, set it up for yourself, see how it behaves, and see how it works. Pretty much all the steps that the templates create for you are setting up even the most complex pieces, like around setting up a mailbox server that sits on multiple subnets and has multiple ENIs associated with it, where there are different security groups for the logical and physical separation between those subnets is provided. So in this first template that we provide, we launch this entire infrastructure and the Active Directory site design. I think for our deployment, we choose a single site design that gets deployed to take advantage of the smart routing that Active Directory inherently provides. Then in the second template, we actually launch the Exchange server as a multi-role server and configure it properly with these ENIs. And we also create for you an uninstall script that gets put directly on the mailbox, onto the desktop for the server. So once all the scripts run through, you're at the position where you then can log into the instance and log in with an already via the template provisioned Exchange admin user that is a member of the schema admins group, so they can perform the right updates to the Active Directory. And you can so you would log in with this user and you would execute the pre-configured unattended install script, and it gets you to the point where Exchange is actually completely running. So what you get out of this, then after this install has completed, you have a fully running infrastructure there in front of you in a matter of a couple of hours, ready to go. All you have to do is set your MX records and create A records for the receive connector and make sure everything is routed properly, and you test your environment and you're up and running. So you move clearly from a couple of days of installation to mere hours, and you have the whole thing up in less than half a day. In a sense, what you get out of it is a highly reliable, no single point of failure. You have Exchange database availability groups across AZs. You have domain controllers across AZs. You have storage availability, and you can if you use a third-party load balancer, you can have load balanced services, and you can linearly scale that solution by adding more servers or storage. Your flexibility to increase or decrease compute, RAM, or storage or business needs is given, and it changes with how your business needs may change over time. something that is quite difficult to achieve when you're in the on-premise world and you make the investments in a specific piece of hardware. What are you going to do with that hardware when it doesn't meet the specs as your business has grown? So you would have to purchase new hardware. In the cloud world, you just simply relaunch the instance with a different instance size. You have a faster processor. You have larger RAM size. From a security perspective, you use least privileged best practices. You use AMIs, the Amazon Machine Images, that are properly hardened and to meet your specific requirements. You can use security groups, which are a concept that are stateful, provide stateful security between instance sizes or subnets, depending on your configuration. In our sample deployment, we use security groups exclusively to actually implement Microsoft's recommended best practices for having the ports open between mailbox servers and Active Directory servers. Yet at the same time, we carve out specific routes directly only from the remote desktop gateways into the either mailbox server roles or Active Directory server roles to ensure that logging into those instances is only given from those endpoints. Let's see. When you install a configuration, be it small like this with a couple of servers, two mailbox servers, combined mailbox server and hub edge transport and casserole, if you combine those and roll it out, or if you even scale it out to a large, like 5,000, 10,000 or more mailboxes environment, then you can actually reap some of the benefits of the cloud environment. You have lower capital expense, you have lower implementation costs and operational costs. You have tools at your disposal that allow you, if you're in the position that you have to implement something more than once, that actually allow you to create templates and scripts that perform these operations over and over for you again. And you actually can prevent dealing with some of the hidden costs that you otherwise would not consider, right? What if your computer storage estimates were wrong? What if you have run through your role requirements calculator, and by the time you got to the deployment, to the real world deployment, your scenario has actually changed. You may have acquired another company. You may need no users. The cloud gives you the flexibility to actually rapidly adjust to these changes. What if there's hardware failure? In the AWS, you have the options to simply spin up new hardware in a matter of minutes and have the same type of, have everything backed up and ready to go. So these are some of the side effects. So when you run this type of environment in the AWS cloud, you have all options that you have in an on-premise world as well. You could use, for example, Microsoft System Center Operations Manager together with Amazon CloudWatch metrics, and have via the Amazon AWS Management Pack direct view into the environment and monitor it on an ongoing basis. You have the instances tagged so they are easily recognizable around in your deployment. If your deployment is small, that may not make a big difference. But as a best practice, you certainly want to make sure that you can properly document what you have deployed, why you have deployed it, what the role of this machine is. you are able to stretch your DAGs across availability zones and insulate them from single AZ failure or failures of instances in a single AZ. If you think about using DAGs with a file share witness, you have actually in most regions the ability to create the file share witness for your DAG in a third AZ, and with it always ensuring that the underlying cluster remains quorum even if something catastrophic would fail and the instances or services in a single AZ would not be available to you and your application. Something just to think about how difficult that would be in the on-premise world to have 3 data centers basically that are geographically dispersed out there. Let's see where we ended up here. Yeah. So we walked through this scenario, and we touched on, obviously, on a high level on some of the pieces that we discussed in great detail in the white paper. But in the end, the AWS Cloud and the cloud infrastructure enables you to deploy high availability and site resilient Exchange server deployments. So, and with that, I want to end and leave some time for a couple of questions here.
Mm-hmm. Yeah, and before we get to that, I just would like to look at the next couple of slides here, Ulf, if you don't mind. We have a couple of customer success stories and case studies which are available on the AWS website. Skip next slide, please. And those are available on aws.amazon.com. The first one is the Choice Logistics and Smartronix case study. There's a webinar that Smartronix did to give an overview of that, and that replay is available on YouTube. The links are in the deck, which will be sent out following this event. The other case study is Banro Corp, a gold mining company, Canadian gold mining company with some African mines and processing. You can read all about it on the website. The next slide is a few of selected partners who specialize in Microsoft Exchange workloads. And so if you want to build a solution but you don't have your own staff that has the expertise that you need, any one of these would be great to work with in order to do that. All the logos link to their entry on the APN website and can be found on aws.amazon.com through the search as well. The next slide is just to promote our reInvent Bootcamp. reInvent is our own AWS conference, second annual this year. Last year was a great event, and this year promises to be even better. There's a boot camp about implementing the Microsoft Enterprise Data Center in the AWS Cloud. Ulf is the expert on that if you want to give any kind of quick overview on it.
Yeah, so this bootcamp is designed for every one of you out there that is considering running one or more of the Microsoft Enterprise workloads in the AWS Cloud. So we will actually walk from simple steps, from the simplest thing of launching just a single Windows instance, all the way through to deploying some complex workloads, including Exchange, like SharePoint, clusters, SQL clusters, and using the AWS deployment technologies like CloudFormation, like the AWS tools for Visual Studio and for PowerShell. So using the tools you already know to deploy these kind of workloads in the AWS Cloud, and so you will walk away with several of those workloads up and running and deployed, and understanding what the individual pieces are that are involved that make this work. And in most of the cases, again, I want to iterate, for the Microsoft workloads running on AWS, it just simply works. They are just small differences that are related to running in a shared compute, network, and storage environment. And we want to learn about those and understand those so you can deploy successfully these type of solutions there.
Great, thank you. And the next slide just gives some further reading. There's the Microsoft on AWS page, which is the aws.amazon.com/Microsoft, the EC2 Windows guide. You can find the Amazon machine images for Windows and SQL Server. You can also find license mobility information, which is how the licensing works between running these Microsoft programs on AWS. You also have white paper links for SharePoint, securing Microsoft and AWS, Windows Server high availability with SQL Server always on, as well as a couple of contact us forms where if you have specific questions or you have a solution that you're looking to implement and have either technical or business questions, you can go and fill out these forms and we'll get back to you within 48 hours. There's the Microsoft one, general, that covers all Microsoft workloads. There's also a SharePoint specific one, as well as the white papers all have an opt-in form on the side of them. So many ways to contact AWS and get your questions answered. Next slide is just additional resources. There's a bunch of links to the same links that are provided within the white paper, the jet stress tool, storage role requirements calculator, the toolkit for Visual Studio, .NET Developer Center, etc. So find those in the deck, which will be sent out shortly. And with that, I'd like to thank everybody for attending today's webinar, and we will cover a few questions. Going to start with a tough one, seemingly to me, but we'll probably understand it better. So with the hub role and the CAS role combined and working on ELB, this question is saying, I've heard it's not a supported method for load balancing to use ELB and hardware load balancing is recommended. Can you speak to that at all?
Yeah, I think I touched on it during the presentation. So in Exchange 2010, ELB is not capable of effectively load balancing RPC-based Outlook traffic to the environment. So for all Outlook clients out there, for all those customers that you want to use Outlook clients against Exchange 2010 in this environment, and you want to load balance this, then at that point we recommend actually using a third-party load balancer for that environment. As I also mentioned briefly, in moving forward to Exchange 2013 with the changes to a single access protocol into the environment via 443, that changes, and at that point ELB is absolutely an option for you. And as I also mentioned, we will write about it and publish it here in the coming weeks, definitely before reInvent.
Excellent. Thank you all. An easier question. What are recommendations on backing up Exchange in AWS?
Yeah. Backing up Exchange in AWS, you will require a VSS-based backup, commercial backup solution. So there are several of those out there, and they are also recommended by the Exchange team. Nothing changes there, but there are also a couple backup solutions out there that take advantage of the integration with other AWS services. So, for example, Commvault's Impana backup solution backs up to S3 directly. Cloudberry's backup solution for Exchange backs up again directly to S3 and or for archival purpose to Glacier. And there are several others out there that do the same thing. So the marketplace is your place to find those solutions, and and use them in this environment. It all depends on what your specific requirements are there.
Great. And could you speak to plans to support Exchange 2013 with this scenario?
Yeah, sure. As I mentioned earlier, we are working right now on updating this paper, or actually publishing a second paper directly around Exchange 2013, and we will do this based on two scenarios: the same small business scenario that we have covered in Exchange with Exchange 2010. And we will also add a kind of a medium enterprise, or it probably depends on your viewpoint for what medium or large enterprise is, but like a 5,000 mailbox scenario that actually involves probably like 12 mailbox servers, and then breaks out also the CAS and edge transport role, which is now combined in Exchange 2013. So we'll cover an enterprise architecture there. Again, look for that before reInvent to be public.
Great. And this is the kind of thing where, in general, it most likely works, but the templates themselves and the specific steps have not been vetted to prove that they work with 2013 at this point.
Right. Yeah, there are specific areas, right? Setting up the infrastructure with these existing templates, that doesn't change because that involves AWS in itself. So these will continue to run. But then how you actually bring down and how you install the Exchange specific bits and how you break this out, there are certainly changes based on the new architecture for security groups to properly route and fence off traffic between mailbox server roles and those CAS edge transport roles. There are specific changes that will need to be made, yes.
Excellent, thank you. Now let's get into a competitive question. What are some advantages of running this kind of scenario versus just setting up Office 365?
Well,
that's cost and scalability and elasticity.
Well, yeah, it's. I mean, in general, we don't. I'm just trying to find.
Customization.
Yeah. So you have in general. Let's focus on the AWS benefits and not so much on like comparing things here with each other. But look at this. You have a host-based security or standards-based compliance. You have full, when you're running on AWS, your full Exchange integrated third-party application support. You have full access to legacy public folder access in modern public folder migration. So you have legacy public folder-based free busy scheduling access. More control over geographic placement and partitioning of data and services. Mm-hmm. Access to the full feature set of the deployed versions of Exchange servers. And these are just some of the benefits that you have when running in the AWS Cloud. So in summarizing it, basically, you have an infrastructure service. The Exchange that you run is the Exchange that you know from your on-premise world, with all feature sets and behaving the same way as in an on-premise world.
Great, thank you. So it's just time for maybe a couple more here. Let me find a good one. Are you able to do block level backup? I imagine with is that possible?
Yeah, so that probably goes towards EBS Snapshot as a backup solution. That would not be a supported solution from the Exchange side, as EBS requires a VSS-aware backup solution. So EBS Snapshot is not an option for you to as a backup solution.
Okay. What about running hybrid between on-premise and online?
And a wonderful scenario for any type of Exchange deployment. You can connect your virtual private cloud via either a VPN gateway or a service that we call Direct Connect, which gives you basically a really big pipe, depending on how much money you want to spend on that pipe, between your on-premise data center and the AWS Cloud, and run the environment in part on-premise and in other parts off-premise, and connect both of those. Your Active Directory site design will probably be one of the biggest considerations there, because you want to make sure that then users that connect into the appropriate CAS servers access mailboxes that are in that individual environment, and you don't have to traverse, if it's a VPN connection, the internet and with that introduced latency there. So you always have the fastest possible performance. But yeah, it's a great scenario, especially if your company is growing, or if you even find yourself in the situation that you want to migrate from Exchange 2003, 2007 to Exchange 2010 or 2013.
Great, thank you. Maybe an easier one. Is there any limitation on data store size on AWS?
No, in theory there's no limitation in AWS. However, you have to consider the realities of the Windows-based environment and the EBS storage sizes that we have in AWS. The maximum size of an EBS volume today is 1 terabyte. If you consider that you have 26 mount points for drives in Windows A through Z, with that you can calculate what the maximum size is of storage you can attach to a single Windows instance. So if you calculate all these things through, like the maximum mailbox size per user, if you have archival mailbox size, online archival mailbox size, then using the role-based calculator, you can easily calculate how big your environment can get. And the scale-out option, especially when you think about Exchange 2013, which is underlying Windows Server 2012, where the failover cluster can be up to 64 nodes. So there are theoretical limits, yes. Are those practical limits? The answer is it depends really on the total size of your deployment. But we get into pretty large numbers there.
Great. I have a question about, can you have, and this is another kind of hybrid question, can you have split topology with Exchange 2010 and AD hosted in AWS linked back to on-premises AD, SQL, Link, Citrix?
Yes, the short answer is yes, but you want to think through the different type of the scenario that you try to enable there. Like accessing SQL Server in the on-premise world, if the connection between your AWS Cloud and based VPC and your on-premise world is via VPN, then accessing SQL Server back to the on-premise world is maybe not the best performant solution. So placement of the individual instance that you want to access from one way or to the other are all considerations that you want to think through from an architectural perspective. Is it all possible? Absolutely yes. But then again, the specific scenario you want to take a good look at and consider what is happening in the connectivity between a cloud-based environment and your on-premise environment. We can give you a very big pipe between those via the Direct Connect service. At that point, latency is not an issue at all. If you connect via VPN, you want to consider that this traverses the public internet with all its benefits and also its shortcomings.
Mm-hmm. Mm-hmm. Great, thank you. What about cloud IP space hurting outbound delivery? Is there reputation issues when using the cloud IP address space, and is there any solution or mitigation for that?
Yeah, actually we wrote a short section on that specifically in the white paper. AWS, when you run a mail service out of AWS, we obviously want to make sure that it's not used for any malicious purpose, spamming or et cetera, or other things. So you will, when you deploy your AWS-based Exchange solution, you want to register those elastic IP addresses, the IP addresses that are actually then communicating to the outside world, to any other servers, and where SMTP traffic runs over. You will have to register those with Amazon, and you also have to go out and register those with typical spam control organizations like spamhouse.org and others. But take a look at the white paper. We've written up exactly the steps involved and provided you direct links to the forms you want to fill out once you put this environment into production. During testing, you don't have to worry about it because you're probably not sending thousands of mails during testing time, but once you put it in production, you definitely want to take those steps before putting it into production and register with all those anti-spam organizations up front.
Great, thank you. So another, hopefully a little easier question. We covered regions and availability zones, but what about edge locations relevant to an Exchange scenario?
It's hard to say. Edge locations.
Is there some way to get even higher availability leveraging those?
No, not really, because you access your first of all, in Exchange 2010, you have the role of the edge transport server, as you're aware. So with that, in an enterprise deployment, if we would have published the small 250 mailbox scenario as an enterprise scenario, we would have probably split out the roles, like from a mailbox server role, the edge transport role, and the CAS role, and put the edge transport server into a D&Z environment and make it a separate role. So from that, there are benefits when you deal with a large scale environment. In a smaller environment, the combined server roles is an entirely acceptable practice and performs well. The IOPS required for those roles are predictable and calculable. So once you know the profile of your users and how many things you have going in and out, these are normal planning considerations that you would apply there.
Mm-hmm. Okay, great. Thank you. Yes, do you want to wrap up one more? All right. This is a question about storage performance with EC2, and specifically, is there an SLA in place for storage performance, and are there different tiers of performance available?
Yeah, so you have standard EBS performance. You have standard EBS volumes that are a shared storage environment. Performance will vary depending on the environment that you work in. But we also offer you provisioned IOPS, which gives you an SLA for the IOPS that you provision. And I can't recall exactly how the SLA for the PROPS is written. You might want to look this up it's actually I've written about it in the white paper as well. But it gives you exactly the IOPS that you calculate out of the role-based calculator, and you provision your volumes accordingly. So we have during the course of producing this white paper, we ran quite extensive jet stress tests against the environment, and we found that we get the very best performance with PIOPS volumes, and this performance is totally predictable, and it delivers the results that you need.
Excellent. Well, thank you, Ulf and Carrie.